When I mention the world of manufacturing, what comes to mind? A constant drone of machinery and fluorescent lights? Endless conveyor belts transporting cogs and sprockets from here to there? A worker standing on that line, watching those sprockets and their future just zip by? Pretty grim, if that were still the case. Thanks to artificial intelligence, technological advancements, and increased cybersecurity, the world of manufacturing is not what it was a few decades ago. In this episode, we welcome two experts who discuss the current state of the manufacturing industry, its rise in efficiency, and the potential security issues that go along with it all. I'm Amanda DeJong, and you're listening to Now at Ohio State. We talk with researchers, innovators, and bold thinkers who look at our world, see what the real challenges are, and create the solutions that people need now. To say that the industry has done a 180 would be an understatement. Gone are the dingy, loud, numbing warehouses of parts and machines and jaded workers. Today, manufacturing plants are almost sterile. They're bright, automated, connected. By leveraging AI, data analytics, and constant connectivity, the manufacturing industry has essentially reinvented itself to become a whole new powerhouse of sorts. But what's really interesting is that the United States isn't really keeping up with these dynamic shifts, at least not yet. Glenn Dane is a professor of metallurgical engineering and materials science expert in Ohio State's College of Engineering. Glenn has been with Ohio State since 1988, so he's had a front row seat to these transformations. Our Jacob Carrozza sits down with Glenn to discuss a new state of manufacturing, why America has fallen behind for the moment, and what's being done to bring us back up to speed.
Glenn, thanks so much for joining us today.
Thanks. Great to be here.
So you've been at Ohio State since the late 1980s. So much has changed in that time, obviously. You've gotten to see the manufacturing industry transform as technology has progressed. So give us the short history. How has manufacturing changed in that time?
Yeah, it's really been interesting. There's the technical piece of things, which I think is a very positive story. So when I came here, things were really done largely with simple equations and calculators and things like that. Now we've got these great numerical tools. At the same time, there's been a couple of things that are, I think, concerning. Back when I joined, the United States was really the undisputed leader in manufacturing, no question about it. And since that time, we've really lost our edge. We've become a country that imports about 1.5 times as much as we export. And as a result of that, there's loss in facilities, loss in jobs. And if you're not making today's technology, it's hard to innovate what's going to be tomorrow's technology. So that's a significant problem.
Now, what's really driven that change? Why is the U.S. importing so much more than it's exporting these days?
Yes, a lot of things. So, from an economic point of view, it may not be such a bad thing, but from a skills point of view and everything, it is a bad thing. But it's really, in a way, part of it has been, I think, partly simple economics of trying to chase lower cost labor, and labor is becoming a much smaller factor in everything. It's really more about skills and equipment and ingenuity. The other thing that I think is a little concerning, when I joined, I'd go to technical conferences, and it used to be about 50-50 between industry people and academics. And these days, it's more academics talking to other academics. I think there's a bit of a rift between industry practice and what we do in academics. And that's something that I really believe we have to fix up. We really need to have the academics engaged with industry so we know what the most relevant problems are these days. And we shouldn't be leading 20 years ahead. We should be leading a few years ahead, I think, is where we really want to be.
Right, and I think that gets to some of the work you and others are doing here at Ohio State. So tell me about Hammer. You're the director of Hammer. It's a new engineering research center here. This is something that involves multiple institutions, and I believe you have funding from the National Science Foundation.
So very grateful to National Science Foundation. It's a relatively large award. What I'm really most excited about is it's intended to be a long-term award. It's intended to be a 10-year award. It's a very serious review after 5 years. We want to be in a position to pass that.
With everything going on at Hammer, what excites you the most?
It's all about people and culture in the end. And so far, I think we're building the right kind of culture where we have great people involved. And we're trying to really get what was like a Silicon Valley-like culture going, where it's really try to pay forward, just worry about creating value. Don't worry about everybody's bit of credit and all of these agreements, non-disclosure agreements and contracts, but just try to figure out how to make value and be fair about distributing that. And we seem to be doing that. So that's what I'm most excited about. And then the technology itself is also awesome. I mean, robots that can make things, can make almost anything, make it at high quality, make it at very small lot sizes. And of course, we're using things like lasers and red hot metal and lots of things to like. So that's what's fun about it.
Yeah, tell me a little bit about what you see as the role of the land-grant university in this sort of project.
Yeah, so I'm a big believer in the land-grant university mission. I mean, we are here, we are all recipients of taxpayer funds. I take that seriously, and we are here to improve lives for people in Ohio and the Midwest in general, give them skills that they can use. We want to make them job ready, but we want to go beyond job ready. We want to make them ready for jobs that we haven't even dreamed exist right now. But the future keeps coming faster and faster, and we don't know where we don't know what's going to be next. And we want to prepare our Ohio State students to have, the physical fundamentals that don't change, but also the ability to see, I can put these things together differently and go out and do that.
Right, and that's one of the great things about Ohio State, that it's this world-class institution with world-class facilities, but it's accessible to the people in Ohio. What role does Hammer have to play maybe in the local economy in helping to spark a bit of a revival of manufacturing in Central Ohio?
We want to be a crucible for small companies to be born, thrive, and then maybe sell off divisions into larger companies. We honestly believe that this area of hybrid autonomous manufacturing can be the next big thing. Columbus doesn't get enough respect for what it has. I mean, we have a great manufacturing economy here. We're really, I think, the center for materials joining. We've got a great welding engineering program here. We have great background in welding and corrosion and so forth, and inspection. So as a result of that, there's a lot of pipeline work that comes in here with companies like DNB and these things with structural components and all that. We want to go the next level with that and grow the economy even more with these great high-tech jobs. I think the future is very, very bright for Columbus here.
I want to talk about workforce development. As we've talked about, when people think of manufacturing jobs, I think they have certain images in their mind, but these are different sorts of jobs than we've had before. What is Hammer doing to really train the next generation?
So we're doing a few things. I mean, a lot of us here, within the universities, we won't be able to scale the way we'd like to. So we're spending a lot of our effort on really training the trainers. So we're working with high school educators, and we want to work with community college instructors and the like. But we want to do things efficiently so we can scale as well. So we're developing courses and certificate programs that can be rolled out to high school teachers, community college instructors, working professionals as engineers as well.
How exactly are you going about teaching high school teachers to explore these sorts of issues?
So we are leaning in hard to a program I've been involved with for many years, the ASM Materials Education Foundation, as we call materials camps for teachers. But it's been fantastic in that these teachers learn material science. They learn the pedagogy of how to teach material science to their students. The teachers love it. The students love it. And the students get a couple of things out of it. First, they get some hands-on skills that they typically don't get, particularly since the shop classes have left. They also get an appreciation for all the careers that touch materials and processes, all the way from skilled trades to PhDs and how that fits into society. All of that is part of that. The students love it. The teachers get to do something different. They engage their students in hands-on activities, again, that they typically haven't done. And it's been great fun. And there are things that really engage the students to think deeply. It shows them that it's not just chemistry that matters, but it's this whole process that really changes how material behaves. And that's really core to how we manufacture things and how material science works. And we teach this at a hands-on, visceral level. It's really, really powerful. Yeah,
it's science education, but with an eye toward the future, with an eye toward what these jobs are going to be like when these students are actually entering the workforce.
And again, we don't overprescribe. We teach them to be creative, ask a lot of what if, what could you do with this?
Yeah, what do you think the teachers get out of this sort of program? Is it a new familiarity with these subjects in general?
They get a couple things. So we get some awesome teachers that come out of this, and they form a community themselves. The teachers get to meet one another, know one another. They form a community. They get a whole bag of tricks of things that they can do in their classrooms that are really engaging. And out of this, we've probably had, in the state of Ohio, about 24 buildings that now teach material science at the high school level. And it's all done a little bit differently every place, which is probably okay. Basic content is all open source. But again, this community forums, these teachers know one another. It's really quite outstanding. It's really an amazingly good program, and all kinds of evidence that it's really, really good for the students as well. And we've got a lot of students that have used this to vector their careers into science and engineering.
Just one final question for you. I think a lot of people, when they hear of AI, autonomous manufacturing, they worry about jobs going away, about being replaced by machines. Is that the reality? Should we be worried about that?
You shouldn't be worried about that. It's going to be a mix of things. So the people that go into manufacturing are people that are going to be doing a diversity of things. They're going to be going in and installing equipment, designing parts, dealing with customers and vendors. But you're not going to be likely the person that's just grinding corners off of castings or something like that. So that's what the jobs of the future look like. The stuff that is not very mentally taxing is absolutely going to go the way of machines. But the jobs that are left are going to be good jobs that have high economic multipliers associated with them. Bringing all that back is going to bring a big multiplier to it. They're going to be very good, interesting jobs of the future without question that engage people's whole brains and whole selves into it. And again, we want those whole people to come from all kinds of backgrounds. That's what makes it socially sustainable as well.
All right. Thanks so much for joining us, Glenn.
Thanks for having me. It's always good to talk about what we're doing.
By now, it's quite clear that the manufacturing industry has grown by leaps and bounds over the past few decades, much of it for the better. But as with any innovation and improvement, there's always another side of the coin, namely security. As more aspects become a part of the Internet of Things and take on remote lives of their own, the risk of infiltration and hacking go up exponentially. Again, Jacob sits down with Ohio State's Vimal Buck, Director of Industrial Cybersecurity at the Center for Design and Manufacturing Excellence within the College of Engineering. They discuss what this new Industry 4.0 means, the threats that come along with it, and what's being done to protect its infrastructure.
Vimal, thanks for joining us today.
Happy to be here.
So we're in a completely different world with manufacturing than we were a few decades ago. We hear about Industry 4.0. So first of all, what does that mean, and how does cybersecurity fit into that?
It was a phrase that kind of originated in Germany, Industry 4.0, in around 2011. And it basically refers to an amalgamation of a bunch of different technologies that are sort of coming together now. So it's referring to the fourth industrial revolution. So you had the steam engine, then you had automation, and now you're sort of getting the connected, data-driven manufacturing. Broadly, it refers to like additive manufacturing, robotics, cloud computing, assisted by technologies such as AI and big data and machine learning. And all of it is sort of underpinned by what we call the industrial Internet of Things, IIoT, which are basically small devices that are all connected, that are sensors that are gathering data and then sending it to decision makers. Whether they be humans that are looking at the data, whether they be AI that's looking at the data, just different processes that are sort of automating and making decisions based on that data.
So in manufacturing, all of these new devices, this brings cybersecurity as an issue really for the first time in manufacturing. How does it fit into all that?
So in the past, what you used to have was systems were basically air-gapped, right? So factories weren't interconnected. And you certainly had machines in factories that had electronics in them, but they sort of did their own thing. They built this process, they did this task. Now what you're seeing is the data from one is feeding into the next. People are using this for a lot of just-in-time manufacturing. It's basically creating a digital supply chain. Mm-hmm. What we saw during COVID was when any small element of this fails, the whole thing can collapse pretty fast, right? Because there's not a lot of redundancy and backups. So what is kind of interesting about this is a lot of the systems and processes that are out there are very old. They're intended to be robust and industrial and run for decades. And even by very old, they could be like, things as new or as recent as the early 2000s, but they weren't designed to be 24/7 online sending data. So in many cases, a lot of these sensors and other things, they're still running with their default passwords because that's what they were shipped with, right? And they work. But now some of them are being modified to sort of also add data gathering and data capability. And that's leaving them increasingly vulnerable because these systems are routinely not patched.
Is there a nightmare scenario for you with all of these manufacturing devices connected to networks now?
So I think what we found out recently was in the first few weeks of the war in Ukraine, hackers were very close to being able to take control of almost a dozen U.S. electric and gas facilities. Oof. So you can kind of see that as a scenario. In a lot of these cases, production can be taken offline of critical or core components. One of the increasing vulnerabilities is with just-in-time manufacturing and other stuff, parts that are designed to maybe fail in like 10,000 hours are a hacker could get in and tweak the process and so that now it fails in 5,000 hours instead of 10,000 hours. That might not be a big deal if it's like a music player, but if it's like a component on a Navy ship or an airplane part, that's a very big problem that needs to sort of be identified and addressed and dealt with. The nightmare scenario is sort of, there's a lot of different vulnerabilities and somebody could come in and do something that takes a lot of production offline in critical areas such as like healthcare or power generation, and that would have like serious consequences, health consequences for a large group of people.
So I know that your work at the Center for Design and Manufacturing Excellence here at Ohio State, you've been focusing on these issues. Tell me about the Secure America project that your team recently worked on.
Yeah, so we recently concluded a project for Secure America, which is based out of Texas. And what we were looking at were low-cost methods and sensors to try to identify when robots have been hacked. The Secure America project was trying to do was for robots, cybersecurity is to say, how do you trust that what the machine is telling you is accurate?
Right.
And one of the ways to do that was to use like cameras, to look at the power line of how much energy the robot is consuming, to even add sensors to human beings and see, could they be yet another vector that sort of shows that the machines have been compromised? Are there other signals? So just look at different low-cost signals to try to verify that what the machine is reporting is what's accurate, and that it hasn't been compromised in a way that is causing it to eventually fail.
Right. And another thing about that project was that this was a really interdisciplinary thing. I think a great example of how cybersecurity in the manufacturing industry, there really needs to be a focus on sharing knowledge. Is that right?
Yes. Basically, it's a shared responsibility for everybody. One of the things that we're sort of finding out is that there is a lack of qualified people in the cybersecurity field and in the general manufacturing field. It's a growing field. It's a relatively new field. Manufacturing in general has had just a shortage where people either haven't seen that it's very high tech or how high tech it is. I think there's different perceptions, and I think CDME is trying to change that by giving students a lot of hands-on access to this.
Now, when you look at the manufacturing landscape, say just here in Ohio, all these levels of security that you're talking about, they do require resources. Do you think most manufacturers are even starting to think about this stuff? How many folks are doing the right thing on this issue so far?
One of the stats that we saw was this, that in North America, we're seeing less than 50% of manufacturers are looking at this. And in Ohio's the fourth biggest state for manufacturing.
Right.
And 80 to 90% of the manufacturers are small and medium businesses, right? So that initial point that we were sort of making, that it's a shared responsibility, a lot of the times there are tools and other things that people are sort of looking at, but those tools are not accepting responsibility for securing your factory. So you're still kind of responsible for that. So you can't really push it down and say, because I bought this firewall or this router, that should have protected me from the hack or attack.
Do you think that there just needs to be more education on these topics for those that are running these sorts of businesses?
There definitely needs to be more education on these type of topics. One of the things that continually we find from surveys of manufacturers and others is that they're just not aware of this or not focusing on this. I think some of it is also probably cost. Anytime you sort of try to implement some of these things to make things more secure, it's going to cost money and time and resources, right? You have to have something now monitoring that. And this is where AI can sort of help, where you can buy software tools that could help monitor different things. But you're going to need to invest some energy into doing that. And I think for whatever reason, we're not doing that as effectively. But the Ohio Cyber Range Institute is a training cyber range that's available to every citizen in the state of Ohio. So all you basically need is an internet connection. And it's available K through 12. It's available to university students. And Ohio State is a regional programming center. So we are creating content and modules for the Ohio Cyber Range where you can kind of go in a virtualized. So it's basically a training range. It was sort of developed with the National Guard, sort of like a firing range where you practice shooting. So here you would be like practicing defensive skills and looking at different things in a safe environment. Ohio State has established the Institute for Cybersecurity and Digital Trust, ICDT. And as part of that, CDME is taking a leadership role in the cybersecurity and manufacturing space there. There's a volunteer cybersecurity reserve force that the state of Ohio has established. and the universities are working with them. OCRI is creating training content. That content is going on the range. They're doing exercises where they're responding to incidents, and a large portion of what they're doing is basically K-12 education, and then doing audits of schools, hospitals, and other places so that they are less vulnerable to ransomware attacks. Mm-hmm. So there are a lot of standards that sort of exist out there, but how do you know how far out of compliance with the standards you are unless somebody comes in and does an audit or an assessment? So a lot of that is just audits and assessments. It's not meant to sort of give you a grade. They're all private. But with the idea that here, this is where you're falling short and you can kind of get better. I think the most exciting thing for me is being able to mentor and train the students. The next generation of people, like you said, 10, 20 years from now, it's going to be a very different landscape. We're already kind of seeing a lot of automation sort of happening. Ohio State has a presence at the national level, and I think we can influence standards, we can work with the national labs, we can work with other universities and get that data published. We can work with the manufacturers. And as we train the students, they are sort of also going into the manufacturing space and then influencing actions there. I think that is very important, and the amplification of all the work that's sort of being done and the potential implications of that are very exciting.
Vimal, thank you so much for discussing this with us today. It was great to talk to you.
Thank you for having me.
It's fascinating to think of what comes next for the manufacturing industry, where it will go, how it will improve not only jobs in the workforce, but society at large. As long as we keep it secured and continue to innovate, the future of manufacturing is looking brighter and more vibrant each day. A far cry from poor George Jetson's time working at Spacely Sprockets, that's for sure. Now at Ohio State is produced by the Ohio State University Office of Marketing and Communications. For more information, visit us at go.osu.edu/now. I'm your host, Amanda DeJong. Thanks for listening, and we'll see you next time.